Hello students! When we are making shapes in video game design, the computer makes the shapes by taking points and connecting them with segments, like this. If I have 4 defined points, like that, it will create a flat surface. So each of those points would be known as vertices, or vertex would be a singular. Each of these segments right here would be known as an edge, and then the connected piece that connects them all together would be called a face. Now the computer needs to be able to move these shapes, and what we have here is these vertices that are connected, but I want it to maintain its shape as I move it. So we have transformations that the computer can perform on the shape in order to move it. The first one that we want to talk about is translation. Now translation, when we're using Unity, would just be called a move. And what that does is it will move the shape in the same direction. So if I take this point right here on the top, and I say I want to move it from here to here, what the computer will then do is move all of the points the same distance in the same direction. So I'm going to select this shape and say I would like you to apply that translation, and it would move it that direction. So you see, if I drew a segment from this point to this point, that same segment, the same distance and the same direction, goes from each set of corresponding points. Okay, let's get rid of these. Now let's talk about our second transformation. Our second transformation is a reflection. So if I want this shape to have a mirror image, this would be in the case of if I had a 2D side-scroller game and I need the character to turn around, I would want a reflection. In order to reflect, I need to have a line that it reflects across. This would be like a mirror. So let me make just a horizontal line right there. So in that case, this would be the mirror. So if I make a reflection, I'm going to say reflect across this line, and then which object would I like to reflect? This one. If I reflect across that line, it looks like that. Now, we can do that in other ways too. So if I change the location of the line, I'm going to change what the reflection looks like. For example, what if I don't have the reflection exactly on the shape? What if it's a little bit further away? And also, what if it's not a straight horizontal line? What if it's a diagonal line? Transform by reflecting it across this line. I want this shape to reflect. Let's go ahead and apply. Now, the way the computer does this is by taking this point, and if I connect it to this line, this intersects at a 90-degree angle, and then it continues past the same distance. So these two little pieces here would be the same. In the same way, right here, this is going to cross at 90 degrees, and these two pieces of segment are going to be the same. And I can do that with the other two pieces as well. You get the idea. The third transformation that we do is a rotation. Now, this is a very common transformation in game design because almost all games involve turning of some type. So, when we have a rotation, we have to have a center of rotation. So think of this, if I'm going to spin this piece around, where would I put my finger so I could spin it? So let's say that I want to spin it around this point right here, and now how many degrees do I want to rotate it? We'll keep it simple and we'll just do 90 degrees. So if I'm going to spin it around this point right here, if this is my center, and I rotate it 90 degrees, I get that point right there. I'm sorry, that shape. Then let's do it again, just for fun. Let's just keep rotating. Now the center of the rotation changes things. So if I do a rotation and I say instead of rotating around this point right here, what if I want it to rotate around this point? Yeah, let's keep it at 90. If I want it to rotate around this point, imagine connecting this point to this point and then spinning it around. Here's what we're going to get. So if you can imagine that, let's draw a segment in here just so we can get a better picture. If you can imagine grabbing this one and then spinning it 90 degrees while focused around this dot right here, we can see that this would end up right there. Oops. Our last transformation is called a dilation. And in Unity, this would be called a scale. So when we scale something, just like a rotation, we have to choose a center. So I'm going to say this one is going to be centered here. Now that we've defined our center, it wants to know our scale factor. And what this is going to do is it's going to increase the size of our shape. So to keep it simple, let's say it's going to have a scale factor of 2. We'll select the shape and say go ahead and scale it up. And there's our bigger shape. Now the way the computer does this is it says, okay, I want to make a larger polygon, so I have this segment from here to here. So in order to do that, it goes from the center to the point and then does it 2 times because the scale factor is 2. Just like this, it would go from here to here and then do it 2 times. Over here, this one is a little bit trickier because it's going to go from here to here and then it's going to repeat that a second time. So these 2 pieces right here are going to be the same length, just like these 2 pieces are the same length and these 2 pieces are the same length. For a slightly better illustration of that, let's get rid of these so we can if I change the center to be right here. Oh, let's go here. If I change the center to be right there, and then go ahead and apply the dilation, watch what happens. Oops. There we go. So what you can see is this point right here would correspond with this point right here. And if I draw segments to it, you can see from here to here is the same distance as from here to here. And from here to here would be the same distance as from here to here. And from here to here is the same as from here to here. One more, here to here, be the same distance as from here, and that's off the screen, so I can't get that. So these are the 4 basic transformations that we'll be using this year in video game design.